Single-image super-resolution (SISR) is a task of generating a high-resolution HR image that corresponds to the input low-resolution LR image. As is well known, SISR is a typical ill-posed problem in the field of low-level vision, since every LR image could correspond to multiple potential HR counterparts. Early classical super-resolution methods restore HR images by optimizing the root mean square error (RMSE) loss function in a supervised manner. This approach forces the model to learn an expectation of all possible HR counterparts, which often leads to blurry results. In contrast, generative SR methods aim to generate HR estimations that conform to the natural image distribution, thereby producing more photorealistic images. Recently, diffusion models have demonstrated strong capabilities in modeling complex distributions such as natural images, showing great potential for generative SR. Early diffusion-based SR works either condition the diffusion model on LR images and train it as a standard diffusion model, or leverage a pre-trained diffusion model as a prior and adjust the reverse process guided by LR images. Although these methods produce good results, they usually require hundreds of inference steps, leading to slow generation. To accelerate inference, several attempts have been made. Some studies explore advanced sampling strategies to reduce the number of diffusion steps, while others propose to model the initial state of the diffusion process as a low-quality image perturbed by slight noise instead of pure noise, which greatly reduces inference steps for generative SR. Furthermore, SynSR reformulates the inference process of Ray's shift as an ordinary differential equation ODE and directly distills it into one step. However, as pointed out in previous work, the performance of a one-step student model is limited by its teacher model. If the ODE of the teacher is not rectified to be straight during training, direct distillation can only yield suboptimal results. Moreover, distilling a teacher model requires multi-step sampling to generate training data pairs, which significantly increases the training cost. Beyond these approaches, some stable diffusion-based methods leverage the powerful generative capabilities of pre-trained stable diffusion (SD) and achieve impressive single-step SR results. However, their reliance on a fixed backbone limits scalability to smaller models, restricting practical applicability. Therefore, how to obtain a distillation-free and backbone-independent one-step generative SR model that can produce photorealistic results with limited inference cost remains a challenging problem. To address the above issues, we propose consistency trajectory matching super-resolution (CTMSR), an efficient generative SR approach capable of producing hyperceptual quality HR images in just one step. Instead of distilling a one-step model from a pre-trained generative SR model, we leverage recent advances in consistency training (CT) to directly learn a mapping function from noisy LR images to HR images. The proposed CT strategy allows us to directly learn a probability flow ordinary differential equation (PFOD) trajectory, thus eliminating the limitations of pre-trained multi-step diffusion models. Moreover, based on the learned PFOD trajectory, which is capable of transitioning the noisy LR distribution to the natural image distribution, we propose a distribution trajectory matching DTM loss to further improve SR results. This DTM loss penalizes the discrepancy between the distributions of our generated SR results and real high-quality images at the trajectory level by matching their respective PFODs. This leads to significantly enhanced perceptual realism. Extensive experiments on both synthetic and real-world datasets demonstrate the superiority of our method. With minimal inference cost, CTMSR achieves state-of-the-art photorealistic SR results.